So in our previous lesson, we looked at the two different types of bonds that can form between elements, covalent bonds and ionic bonds. In covalent compounds, which have covalent bonds, the electrons are shared. Whenever electrons are shared, it always occurs between two or more nonmetals. If you think to the way the periodic table is organized, everything to the right of the metalloids or the semimetals are considered nonmetals plus hydrogen. So for example, water, H2O, hydrogen is a nonmetal, oxygen is a nonmetal, so this would be a covalent compound. Ionic compounds form when electrons are transferred. This always occurs between a metal and a nonmetal, such as sodium chloride. Na is a metal, chlorine is a nonmetal, so that would be an ionic compound. Whenever we've looked at atoms so far, especially when drawing Bohr models, we've always said the protons and the neutrons are the same. So this means that all of the atoms we've looked at on the periodic table have been neutral. There's no overall charge because for every positive charge, there's also a negative charge that balances each other out. Bonding, or the transfer or sharing of electrons, occurs due to the octet rule. Remember, when you hear octet, think octagon, think octopus. Every element wants to gain or lose electrons in order to get 8 valence electrons for a full outer orbital. Remember, the caveat to that is hydrogen and helium, which both only need 2 to be happy. So the new part comes in with our ions. Ionic compounds involve the transfer of electrons. Whenever electrons move from one atom to another, that means the atoms start to become charged. When an atom has a charge on it, either positive or negative, it's called an ion. We have two different types of ions. Positive ions are called cations, and negative ions are called anions. And I think this got cut off a little bit, so I'll write it right beside it. A way to remember this, if you think negative anion, it has an N in it for negative. If you think positive for cation, think of about a little positive cat nose with some whiskers, and we have a cation. Whenever cations form, our neutral atom that we start with loses an electron. It could lose 1, it could lose 2, or so forth. And since it has more positive protons than it does negative neutrons, that means it has an overall positive charge. Again, anytime an atom loses an electron, it becomes positive. When figuring out if a cation or anion is going to form, you look at the group number to get the valence electrons. All of the metals in groups 1, 2, and 3 become cations because they lose their valence electrons. It's easier for them to lose those outer electrons and have the full shell underneath than it is to gain electrons to get up to 8. Anions are reversed. A neutral atom gains electrons, and then it has more negative electrons than it does positive protons. This gives it an overall negative charge. So every time an atom takes electrons, it becomes negative. Again, we look at the group number to get the number of valence electrons. Elements in groups 5, 6, and 7, or the nonmetals, become anions because they are bringing in new electrons. Again, they need to bring in enough electrons to get to a full shell of 8 according to the octet rule. So if you think about a group 2 element, what would it have a charge of? Well, it's in group 2. We know that elements in group 1, 2, and 3 will lose electrons to become positive cations. An element in group 2 has 2 valence electrons that it needs to get rid of to have 8 below. So that means it would have a charge of positive 2. And you'll notice on this, we don't write positive 2, we write 2 positive. It's just one of those picky things that chemists like to do. If we look at iodine, it's in group 7, so it has 7 valence electrons. It needs to bring in 1 extra one. Whenever an atom brings in an extra electron, it has a negative charge, so iodine would be -1 or 1-. The charge always depends on the number of valence electrons, and this table will walk you through each group. So if we look at group 1, there's one valence electron. They will lose that one electron to have an ion charge of +1. Group 2 has two valence electrons. It will lose those 2 electrons to have a charge of +2. And group 3 will lose 3 electrons to have a charge of +3. And again, when we lose electrons, it means that we just have more protons than we have the negative electrons, and that's where the charge comes from. For nonmetals, it's opposite. In group 5, they need to gain 3 electrons because it's easier to gain 3 than it is to lose 5. So that gives it 3 extra electrons and a charge of -3. Nonmetals in group 16 or 6A have 6 valence electrons, so it's easier for them to gain 2 than it is to lose 6. Those 2 extra electrons gives it a charge of -2. And in group 7, 7 valence electrons, they will gain 1 to have a charge of -1. And we've mentioned the noble gases and how they just kind of chill because they already have 8. So this is a typo. They don't actually gain. They don't actually lose. They don't do anything. They just stay where they are because they've already satisfied the octet rule. So if we do an example, if we think about lithium, how many valence electrons does it have and what would the charge be? Lithium's in group 1. It would have 1 valence electron. It will lose that electron to have a charge of +1. Whoops. Let me go back. If we look at nitrogen, nitrogen's in group 5. It has 5 valence electrons. In order to get 8, it's going to bring in 3 additional electrons to have a charge of -3. And if we look at this, I want you to think about looking at nitrogen on the periodic table. Let's say that nitrogen has 7 protons and 7 neutrons. Has 7 electrons in the Bohr model, 2 in the first shell, 5 in the second, pardon the sloppiness. So if you notice, we have 7E and we have 7P. It's balanced, but nitrogen needs to bring in 3 more electrons, 1, 2, 3. So now we add 3 to our electron total to get 10 electrons total. So now we have 3 more electrons than we do protons, and that's where the -3 charge is coming from.